Anybody tell me what that place is? It is not the Louvre. Good guess, but it is not the Louvre. That's it. Perfect. Rock and Roll Hall of Fame. You ever been there? How many people have ever been to the Rock and Roll Hall of Fame? And you didn't know what it was?
No, we didn't know what it was.
Oh. Okay, follow-up question. You're out for a few minutes. Where's it located? Okay, you're out too. Where's it located at?
California.
Is it around here?
See, they've all been there. I've been there twice. So it's not super far.
Pennsylvania?
Pittsburgh.
And
New York.
Ohio.
this is a football.
San Ohio.
Ohio?
Yeah.
What part of Ohio?
Canton.
No. This is the football stadium right here.
Ohio State.
No.
Johnny, it's in Ohio.
Cleveland.
What'd you say?
Cleveland.
There we go, Cleveland. Bingo. That was painful, but we finally got it. Yeah, this is in Cleveland, Ohio. So, I was really amazed the first time I went there. When you pull up, so you got this big giant glass thing. Okay? Then you walk in the front door, like there's the metal detectors and like a gift shop and like a little place to eat. And that's some pictures. And that's basically the entire pyramid. I'm going, wait a second, I just paid $40 to walk in here. All right, so all of this in front is like concrete. Well, after you go inside of it, this big pull-up area, the museum is back and underneath this concrete. This thing is massive. I mean massive. It's probably, I think there's like 5 stories. There's I think 2 stories that are, the main floor is all underground. I'm gonna say it's probably the size of, at least the size of the high school, and that's filling in the middle, courtyards in the middle.
Oh, God.
I mean, it's huge. It's just you go from room to room to room, and then there's like this feature room up top, and there's a spiral staircase walkway over here where people like sign their names on the wall and then they engrave them. There's different plaques and stuff. It's just really, really cool. But one of the big things when they designed it, the guy that picked design it was actually a former mathematician. He wanted to show a lot of mathematical concepts. All right, so we got the triangles, we got concentric circles, we have what looks like an infinite spiral staircase over here. It's just really neat how it was designed. It's way different than anything else that was done. And then on top of it, it's sitting right on the bank of the Lake Erie. So this is the front. Out the back, what you're looking into, so actually this is Lake Erie out back. This is the Cleveland Browns Stadium. There's what, a submarine sitting out back, I think? At least there was one, but there's a submarine sitting out there you could swim. Kickball. So it's just pretty cool. I always like to I like to bring that picture up to start this off because, I mean, it's got all the elements of geometry right there in it. So today, we're going to talk about angles, different types of angles, and angle pair combinations. So first off, we have some vocab words. All right? Wouldn't be a bad idea to write some of these down, just saying. All right, so angles. To measure the size of the opening between 2 intersecting lines. And the lines are the sides of the angle, and the intersection is the vertex of the angle. So if I draw this up here, maybe I'll draw it. Oops, I'm not on eraser mode, huh? So this would be an angle. This is the vertex right there, that dot where the 2 come together. This would be a side. This would be a side. And then this would be what you would measure at. Okay, this would be whatever that is that would have an angle degree measurement. All right. And then from there, one of the big things is how you name an angle. Okay, you can name an angle 3 different ways. I'll show you this in a minute. Okay, we good? All right. Now, naming an angle. So, there's 3 different ways you can name it. By vertex, by the 3-letter method, or by designation. I'll show you what these 3 mean. This one here is kind of your foolproof one, though. All right? So, I'm going to draw an angle here. I'm going to let's say this is point B, point A, point C. Okay? So, the first way, if I'm talking about this angle here on the right, if I want to name it by the vertex, what point is at my vertex? B. So I could say it is angle B. Second thing, 3-letter designation or 3-letter method. I could use all 3 letters that make up the angle and make sure my vertex is in the middle. So I could say ABC. What could I also say? CBA. You guys remember doing this in geometry? Okay, the big important part is here and here is the vertex, right? Both those angles are exactly the same. Last thing, by designation, sometimes they'll put like a little 1 in there. So that's angle 1. And then you can name it like that. I don't like that one very well. Okay? To be 100% honest with you, to me, the 3-letter method is by far the best. Here's why. So right now, if you say letter B or angle B, I know exactly which one you're talking about, right? Or even angle 1. Now, what if I do this? I'll take away this 1. So we can still call it letter or angle B. If I do this. Now, if I say angle B, what the heck angle are you talking about? You have no idea, do you? There is none. This, if you're just calling by the vertex, this has a vertex of B. This one does, this one does, this one does, that one does, that one does. You see what I mean? So there's 1, 2, 3, 4, 5, 6, 7, 8. 8 different angles at least that you could call angle B. But if I call it ABC, is there any question which angle I'm talking about? No. All right? So you don't always have to use the 3-letter one, but when in doubt, use the 3-letter one. Make sense? Okay, that's the 3 ways to name an angle. All right, so we have different types of angles. We have 4 types of angles that we're going to talk about. First off, acute angle. Acute angle is less than 90 degrees. A straight angle is 180 degrees. It makes a straight line. Obtuse angle is bigger than 180 degrees, but less than 360. And a right angle is 90 degrees. How many of you guys remember these? Okay? Those 4 will be on your quiz. Just saying. Less than 90. Yep. Obtuse is between 90 and 180. Okay? There you go. Acute is less than 90. Straight is 180. Obtuse is between 90 and 180, so it's bigger than 90. And a right angle is 90. All right, then after that, you would have, there's other ones too, ones that are bigger than 180. They're called a reflex angle. We won't really talk about those. Save that for geometry. All right? You guys good? You need a minute. All right. Next things, angle pairs. Here's a couple angle pair relationships. Again, this will be on your stuff. These 2 and then 2 on the next page. So the first one we have is adjacent angles. Adjacent angles are 2 angles that share a vertex and a side. So look at these 2 pictures I have right here. All right. The one on the left, this angle and this angle. Those 2 angles together are adjacent. They share this side and they share this vertex. Does that make sense? Next one. Here's an angle. Here's an angle. They share this vertex and that side. That's why they're adjacent. They share a side, they share a vertex.
So like,
Okay. Think of adjacent angles as they're laying next to each other, not parallel. Share a side, share a vertex. Adjacent means side by side. Okay, like my room is adjacent to Mr. Bartlett's room. So we're side by side. We share a wall. Then we have vertical angles. Vertical angles are created by two straight lines. So at the bottom, I have two lines crossed and making an X, right? And then I say they're always equal. So this angle and this angle would be equal to each other. Those are vertical angles. This angle and this angle are adjacent to each other, or are vertical angles to each other, and they would be equal. Okay, those opposite angles are equal. Make sense? We'll do some examples of this too, don't worry.
You shave that?
Not since I was like your age.
Really?
Yeah.
That'd be fun. I'd get a kick out.
Mm-hmm.
Look at your face.
Mm-hmm. Good, Marissa? Okay. Last two angle pairs. This is pretty much the end of our definitions, really. All right, so this one here, we have complementary and supplementary. So complementary angles. Complementary angles are angles that add up to 90 degrees. So for instance, in this picture here, say for instance this guy is 40 degrees and this guy is 50 degrees. What's 40 plus 50? 90. So together they make a right angle. This one here is not a right angle, this is not a right angle, but together they make a right angle. Okay? Down here at the bottom, supplementary angles. The sum of their angles is 180 degrees. So this might be 120 degrees. This guy would be 60 degrees. 120 and 60 together, they make up 180. Now again, I'm just giving you specific examples, but they're two angles that together create 180 degrees. Does that make sense? Yes? Give me a thumbs up. Okay. So complementary is 90, supplementary is 180. Here's a lot of people mix these up and try and mix up which one's 90 and which one's 180. This is the way I was always told. C comes before S in the alphabet, right? 90 comes before 180 in number order. Okay? First number, first letter. All right? Complementary, sum to 90. Supplementary, sum to 180. All right, then if you have a triangle, all the angles together, if you add them all up, it's going to be 180 degrees. Okay, we really aren't going to use this right now, but down the road a little bit, we will use that. All right? So here's the big thing I want to get to today. This is our last page of the day, as well as a bunch of examples. So I'm going to give you guys a few minutes here. Drew a picture up here. These are points, okay? Point B, point A, point G, point E, F, D, and C. Okay? This is what I want. I want a pair of adjacent angles. I want a pair of complementary angles. A pair of supplementary angles. A pair of vertical angles. Okay, so each one of these are pairs. Pair, 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 and pair. All right, then I want a right angle, just one. I want one acute angle and one obtuse, and let's go one straight. Okay, so I have 4 of these. 1, 2, 3, 4 are single angles. This is a pair, a pair, a pair, and a pair. Does that make sense? So I'm going to pause it right now, or yeah, pause this right now. I'm going to give you, I don't know, 5 to 10 minutes here. See how we do. big thing on here, guys, I put a whole bunch of examples here. All right? Those are not the only ones. There could be way more answers. I mean, adjacent angles, for instance. I could say this one and this one are adjacent. I could say this one and this one are adjacent. Over and over and over again. If it shares a side, shares a vertex, I'm good. Right? Okay? Same way with supplementary. Same way with complementary. If it makes a right angle, it works. If it makes a 180 degrees, it works. Does that make sense? All right. Last thing I want to do today, talk about using a protractor. Okay. You already know that?
Yeah, we already did that.
Did we do that already? Okay. Just do it one time. One time for a refresher. Okay? If I have this angle right here, I want to use a protractor. I come over here. Protractor's laying out already. All right. Use a protractor. You set. For me, this one has a little cutout here. You guys on the smaller ones, it just has all the lines meet here. You would put all those lines right on the corner, right on the vertex. So I'm going to put it on the vertex, and then make one of those lines. So I'm going to use this one, this bottom one, is going to lay right on the edge. So I set it up like that. Okay? Now, there's two numbers that this intersects with. Is this bigger than 90 degrees? Yes, so I need to pick the number that's bigger than 90 degrees. Because it crosses at about 51 and also at 29, 129. So which one's it going to be? 129. Does that make sense?
Yep.
Okay. All right, I'll put your homework up.